Part 3, techniques to finding the limit of a function. The first type of function we're going to go over is a function whose domain is restricted. So these types of functions can be square root functions. If we look at the first one, f of x equals the square root of x minus 1, we know that the domain for this is x is greater than or equal to 1, because you cannot plug in anything smaller than 1. So if we want to find the limit of this function to any value that's bigger than 1, we have no problem. Like, for example, if we wanted to find the limit of this function as x approaches 5, all we would simply have to do is plug in 5, and we would have the square root of 4, which is 2. However, when x is approaching 1, we have a different story. If we remember what the graph of this function looks like, I'm just going to zoom in really quick here. We remember that we have a value at 1, 0, and then the function goes off like so. So if we try to find the limit as x approaches 1 from the negative side, we cannot approach 1 from the negative side because there is no graph over there. Therefore, the limit does not exist. There must be a road coming from the negative side to approach 1 from the negative side. However, we can approach 1 from the positive side. Therefore, the limit as x approaches 1 from the positive side is 0. So now the limit as x approaches 1 in general would also be dne. The limit must be the same from both the negative side and the positive side in order for there to have a limit at 1. So because the limit does not exist coming in from the negative side, the limit does not exist in general. So this happens with functions whose domains are restricted, and it's only at this particular point 1. So you just have to be mindful when you see a square root function or any other function that has an even root. Now try to do the next example on your own. Try to find the limit as x approaches negative 2 of f of x equals the square root of x plus 2 from the negative side, from the positive side, and then in general. You should have come up with the same answers as the previous problem. The limit does not exist if we approach negative 2 from the negative side. It equals 0 as we approach it from the positive side, so it does not exist in general. Where this could get pretty complicated is if we had a function where we had f of x equals the square root of something like negative x plus 4. And we wanted to find the same type of information. We want to find the limit as x approaches 4 from the negative side of f of x, the limit as x approaches 4 from the positive side, and the limit as x approaches 4 in general. So in this case, if we remind ourselves what the graph of this one would look like, we would be allowed to plug in 4 because we can take the square root of 0. However, we would not be allowed to plug in 5, for example, because negative 5 plus 4, we can't take the square root of negative 1. We could, however, plug in a negative 5 because that would give us a positive 5, and then we could take the square root of 9. So we can plug in the negative values, but we can't plug in the positive values. Therefore, from the negative side, we would have a limit, and it would be 0. We cannot approach it from the positive side since we can't plug in those positive values. So we would get does not exist for the limit on the positive side. Therefore, the limit would not exist in general. Now we're going to discuss how to find the limits of functions at values where there is an asymptote. So if we look at f of x equals 1 over x minus 1, and we want to find the limit as x approaches 1, we can't simply just plug 1 in because that would give us 0 in the denominator. And we know that this guy has a vertical asymptote at x equals 1. So what we need to do is we need to see how the function is behaving at that asymptote. Remember, when we have a vertical asymptote, there are 3 possibilities for the limit at the asymptote. If we have an asymptote and both sides of the graph are going up, then we know that the limit is going to be infinity. If both sides of the asymptote are going down, then we know that the limit is going to be negative infinity. And if the sides are going in opposite directions, then we know the limit does not exist. So we need to see what's going on by plugging in values and kind of testing it out. So for this particular function, we know that there is an asymptote at 1, like we've said before. And we know that there is a horizontal asymptote at 0, since the degree on top is smaller than the degree on the bottom. So let's plug in a value that's bigger than 1, like 2, and we'll see what's going on. So if I plug a 2 into my function, I get 1 over 1, which equals 1. So I know I would have a coordinate up there. And if I plugged in 0, I would have 1 over negative 1, which is negative 1. So it looks like this graph is going to behave this way. So we know that the limit as x approaches 1 of our function does not exist, since the arrows are going in different directions. So why don't you go ahead and try to find the limits of the next 3 at their asymptotes and then replay the video to see if your answers are correct. Okay, so we should have gotten does not exist for number 2. The points are on either side of the horizontal asymptote. And for 3, we should have gotten infinity. It looks like the arrows on each side of the asymptote are both going up and approaching infinity. And the answer for 4 is also D and E.